Good afternoon, everyone. I am Astha Lutare, and today we will discuss question number 4 of internal C. So, our question is to write an algorithm to solve simultaneous linear algebraic equations using Gaussian-Seidel iterative method. Firstly, what is Gauss-Seidel iterative method? A numerical iterative technique used to solve a system of linear equations of the form Ax is equals to b. Unlike direct method like Gaussian elimination, it improves an initial guess over several iterations, especially useful for large systems where direct methods are inefficient or unstable. Now let us discuss when to use it. The coefficient matrix A must ideally be first diagonally dominant, that is, the absolute value of each diagonal element is greater than the sum of absolute values of the other elements in the row, or symmetric and positive definite. Used when approximate solutions are acceptable and fast convergence is desired. Inputs required are first coefficient matrix A, second constant vector b, third initial guess x0, fourth tolerance, and fifth maximum iterations, which is represented by max underscore iter. Now let us come to the algorithm. Input will be coefficient matrix A, the matrix of coefficients of the linear equations, constant vector B, the vector of constant on the right hand side of the equations, initial guess x0 and initial approximate solution vector, tolerance, a small positive number during the convergence criteria, maximum iteration and upper limit of the number of iterations. Second is to rewrite equations. For each equation in a system Ax is equals to b, solve for the variable xi in terms of other variables and the constant terms. This means isolating xi on one side of the equation. That is, iteration counter k is equals to 0, solution vector xk is equals to x0, that is initial guess. Step 3 is iteration. First one is to initialize. Set of instruction counter k to 0 that I have told earlier. Set of solution vector xk to the initial guess xo. For each equation I is equals to 1 to n, now we are coming to repeat in a loop for each equation I from 1 to n. Calculate the new value of xi using the rewritten equation, substituting the largest values of xj that have been calculated in the correct iteration. Update xk with the new value of xi. Then convergence check. Calculate the difference between the current iteration solution xk and the previous iteration solution xk minus 1. If the magnitude of the difference is less than the tolerance or the number of iteration exceeds the maximum, then the algorithm has converged. In simple words, we can say that after each iteration, compare xk plus 1 and xk. If the change in all values is less than tolerance, convergence achieved. If not, then repeat iteration. Else, exit with warning may not be converged. And the next is, if the iteration is converged, then we will come to the output. If the algorithm converged, the final solution vector Vxk is the approximate solution to the system of equations. If the maximum number of iteration was reached without convergence, the algorithm may be failed to converge. In this case, the last calculated solution is the best approximation, and it may be necessary to reevaluate the parameters or use a different method. In simple words, we can say if converged, final solution vector xk is accepted as the approximate solution. If not converged, return last calculated vector as the best approximation. What are advantages of Gauss-Seidel method? It is simple to implement, efficient for sparse matrices, can be faster than direct methods for large systems, and at last it is suitable for parallel computing with modifications. Now in conclusion, we can say that Gauss-Seidel is a powerful tool for iterative solutions. especially useful when exact answers aren't needed but efficiency is. Important to check convergence condition before applying. Thank you for listening.